Okay, everyone. Today we're diving deep into something called access control lists, or ACLs. Now, these are way more than just lines of boring code. Think of them as the unwritten rules of the road for your network. And if you get a handle on these key principles, believe me, it makes all the difference. So let's get right into it.
So everything really boils down to one simple question. You've got this massive flow of data, right? Constant traffic. How do you, the person in charge, decide what's allowed to come in and what gets stopped right at the door? I mean, that's the core challenge of network security, isn't it?
And the answer to that question? Well, you hire a bouncer. And for your network, that bouncer is the access control list. The ACL's job is actually pretty simple, but it is absolutely critical. It just stands at the entrance and it checks the ID of every single packet that tries to get in. It decides who's on the list, who gets thrown out, and it follows a really specific set of rules.
Okay, so before we get to the secret handshake and all those unwritten rules, you've got to know your tools. Think of it this way. There are two main types of bouncers you can hire. You've got your standard ones and you've got your extended ones. Understanding the difference? That's your first big step.
A standard ACL is, pretty basic. It looks at a packet and it only asks one question. Where are you coming from? That's it. It only filters based on the source IP. But an extended ACL? Whoa, that's a whole different ballgame. It's like a full-on interrogation. It asks, where are you from? Where are you going? What protocol are you using? And what door are you trying to get through? All that extra detail, it gives you this incredibly fine-tuned control over your traffic.
Oh, and just a quick side note here, you can also give these lists actual names instead of just numbers. So instead of trying to remember what ACL 101 does, you can just call it something like block guest Wi-Fi. It's a really simple change, but trust me, it makes managing everything so much easier. All right, you've met the bouncers. You know the difference between them. Now it's time for the real insider knowledge. These are the rules you're not going to find all collected nice and neat in some textbook. Nope. This is the stuff you learn the hard way, out in the field. And today, we're giving you the shortcut. Pro tip number 1, and this is a big one. You only get one bouncer per door per direction. What does that mean? It means one ACL for traffic coming in on an interface and one for traffic going out. If you need to check for a bunch of different things, you don't hire more bouncers. You just give your one bouncer a longer, more detailed checklist. Now, listen up, because this one is absolutely critical. Your router reads an ACL from the top line down to the bottom, and the very instant it finds a rule that matches the packet it's looking at, it stops. It just stops reading and takes action right then and there. So the order of your rules isn't just important, it's literally everything. Let's walk through a quick example.
Okay, so here we go. A packet from 172.16.1.1 shows up. The router looks at rule number 1. Does it match? Nope. So it moves on.
Now it checks the second rule. Still no match. On to the next one. And then it hits rule 3, and bingo, we have a match. The router immediately drops the packet. And here is the key part. It stops processing the list. Done. It never even looks at any of the rules that might come after it. So what's the big takeaway here? Let's say you had a rule later in that list to permit all traffic from the entire 172.16 network. Well, too bad. That rule would never even be seen. Your very specific rule to deny that one single computer has to come before the more general rule to permit the whole network. Always, always, always put your most specific rules at the top. Okay, quiz time. Take a look at this ACL. Pretty simple, right? It permits traffic from 3 different networks. Now, a packet arrives from 172.20.1.1. It clearly doesn't match any of those permit lines. So what happens to it? Does it just get a free pass and waltz right through? The answer is a hard no. And this is the next unwritten rule that trips up so many people when they're starting out. At the very bottom of every single ACL you create, there's an invisible line of code. It's silent. You can't see it, but it's there, and it says, deny everything else. It's a fundamental security feature, a fail-safe. It means if you don't explicitly say yes, the default answer is always no. You know, seeing this really makes you appreciate how much easier things are now. Back in the day on older systems, you couldn't just pop in and edit one line. No way. You had to perform this 6-step open heart surgery on your config. You'd remove the ACL, Copy it all to Notepad, make your changes, delete the original from the router, paste the new one in, and then reapply it to the interface. It was so clunky, and it really makes you love modern named ACLs, where you can just edit lines one by one.
All right, let's do a quick lightning round of pro tips for smart management. First, a router can't filter traffic that it generates itself. That can drive you crazy when you're testing things. Second, if you need to turn an ACL off for a bit, don't delete it. Just take it off the interface. It's way easier to put back. Third, if you want a consistent security policy, reuse the same ACL on multiple interfaces. And finally, keep your lists short and focused. Don't overcomplicate things.
Okay, so we've covered the rules of what you should write in your ACLs, but now we've come to the final and maybe most important piece of the puzzle. Where do you actually put them? This is where good network design really separates the pros from the amateurs. Because placement is everything. There's a mantra, a golden rule, that comes straight from Cisco, and every network pro I know lives by it. And it goes like this. Place your extended ACLs as close to the source of the traffic as possible, and place your standard ACLs as close to the destination as possible. You should probably burn that phrase into your memory. So why? Why does this matter so much? Well, think about it for a second. Because your extended ACLs are so specific and powerful, you can use them to block unwanted traffic right where it starts. This stops that junk traffic from chewing up bandwidth and processing power all the way across your network just to get dropped at the very end anyway. It's all about being efficient and saving your network's precious resources. So there you have it. You've got the toolkit, you know the unwritten rules, and now you have the strategy for placement. You're not just typing commands into a router anymore. You're actually architecting a defense system.